Okay, let's look at an example of setting forth along different paths. All right, so let's look at the same force as the previous example. Force is y squared comma 2x comma 1. And the starting point is the origin, just like before. And ending point is 1 comma 1 comma 1, just like the previous example. But we're gonna take a different path. This is along a part of a circle and then go straight up. So let's see. If you rewrite this guy right here, we can write it as x squared plus y squared minus 2y. I'm gonna add 1 to both sides of the equation so that we can complete the square. Oh, actually, I have to put 1 there. So I have to add 1 to the right hand side too. Alright, then we can write it as x squared plus, complete the square, so we have a y minus 1 squared is equal to 1. Alright, that way we can see that the radius is 1 and the center is at 0 comma 1, and of course z equals 0. Alright, so we're looking at, let's see, center is going to be right here, 0 comma 1, and it's a radius 1 circle, so it's going to look kind of like this. Alright, on xy plane. So what we do is we start from the origin and go along along the circle, and then you get here, then go straight up to the destination here. Right, so last time I believe it went like this, go here and go straight up, and then ended up with the same point. Right, and that path, the work came out to be 3. So along that path, I think a work came out to be 3. Right, so we have the same force, same starting point, and the same destination point. And let's see if we can get the work along a different path. Alright, so in order to find work, so W, that's going to be equal to, so it's going to be a still line integral, right? Y squared dx plus 2x dy and plus dz. Alright, so let's call this path, let's see, I1 here, and here is going to be I2. Oops. Here's the, oh actually, maybe I should call it this since it's a path, so P1 and P2. Right, so we want to find, maybe go here, we want to find an integral over P1, and so we're going to split that into 2 integrals so that we can take care of them separately. Alright, along P2, same thing. Alright, so I'm going to call this guy work 1, and call this guy work 2. Alright, so let's do the easy one. I'm gonna cheat a little bit. I'm gonna set it up and just find the value. Let's see, W2 is easier. So here, since you are going along the path 2, which is just going straight up, which means that x never changes, y value never changes, only z value changes. So you can see that these two terms are going to be 0 because there's no change. So dx is going to be 0, dy is going to be 0. So you just end up getting integral from 0 to 1 dz. right? This one's easy enough. You know, antiderivative of 1 is z from 0 to 1, so it's going to end up getting 1. All right, and the W1 is a trickier one. I'll help you guys set it up. All right, so this is going to be, so along this path, all right, so how do we express that? All right, so if you do standard parameterization, so for example, if you do x equals, radius is 1, so it's probably just a cosine of t or, t or theta. Oops, that's not it. All right, I'm going to do say theta, right? Y equals a sine of theta, right? This would just give us the unit circle centered at the origin, so which is not quite what we want. So it's gonna give you this circle, right? Unit circle there, centered at the origin. So we need to shift this guy over to the right, or in the positive y direction by 1 notches. So the way to do that would be just +1. Right? Then we can find differential. So dx, dx is going to be negative sine d theta, and the dy is going to be cosine of theta, theta, d theta. All right, so let's do this. So along path 1, so this along this circular path, it's going to be, all right, so we just have an integral. All right, theta is going to be, let's see, from negative pi over 2 to 0. So negative pi over 2 to 0. All right, so y squared would be, y is sine theta plus 1 squared. All right, then dx came out to be negative sine theta d theta. Right, and 2x is 2 cosine theta. dy is cosine, so it's a cosine squared d theta. And the dz, there's no z change. dz is going to be 0. So this is that. And this comes out to be, so I'll let you guys compute it. It came out to be 8/3. Right? So which means that the work that we were looking for is just a sum of these two works. So it's going to be 8/3 plus 1, so which came out to be 11/3, right? Which is not the same as 3. So obviously, if you have, even if you have the same path and same force, same starting point and the same destination point, by taking a different path, you're going to end up doing a different amount of work, right? So, but if there is a force, kind of forces that the work is always the same regardless of the path you take. Those kind of forces called the conservative force, which is going to be the next topic. All right, that's it. I hope that this was clear.